Okay, so this is going to be all 3 review pages of the optimization test review. The symbols for the different types of functions, cost is C of Q or C of X. Average cost, we denote that with a little c of X, which is the total cost divided by the number of items. Revenue is R of X. It's the money you earn from sales. And profit, we use pi, and that is revenue minus cost. Now, anything that says marginal is the first derivative. A shortcut for finding the marginal cost, if we want to find for n units, if we find the next unit cost minus the cost of that unit. So, for example, if it said find the 10th unit approximately, that would be C of 11 minus C of 10. Okay, so for number 1, it wants to know the quantity that the profit is maximized. So first I need a profit equation, and I'm going to change all my variables to X. So that's revenue minus cost. The parentheses are important because this negative gets distributed. So the profit equation is 450x minus 10,000 minus 3x squared. To maximize it, we need the first derivative. That's going to be 450 minus 6x. And when the first derivative equals 0 is when you have a max or min. And now we have to solve this equation. I'm going to add 6x, divide by 6. We get 75 items. So that's the quantity. What is the total profit? We're going to take the 75 and plug it back in to the original function. So we'll do 450 times 75 minus 10,000 minus 3 times 75 squared, and that is $6,875. Now for number 2, we have to find a revenue equation before we can find our profit equation. So the revenue is 588x. So then profit is 588x minus the entire cost equation. So I'm going to distribute the negative, and I should be using x. I'm going to distribute the negative as I write it. And then I can combine the like terms of 588 and negative 12,000. I'm sorry, 1,200. So my profit equation is negative x to the third plus 60x squared minus 612x minus 1,000. And then I need the derivative. Set it equal to 0. And I really do not want to factor this. So the easy way is if you, on your graphing calculator, plug this into y1 and look for the x-intercepts. And you'll have to expand your window because our two x-intercepts are 6 and 34. Now we have 2 possible values that would make the profit a max. Well, one of them might be a minimum and the other one might be a maximum. So we're going to determine the difference by plugging it in back to the original profit equation. So if I do the profit of 6 and the profit of 34, the profit at 6 is negative 2728 so $2,728, and the profit at 34 is $8,248. So the maximum is at 34. The minimum is at 6. Now there were other parts to this question. Find the total cost, revenue, and profit at this level. So we need to find cost of 34 and revenue of 34 as well. So when we plug 34 into the revenue equation, 588 times 34 is 19,992. And when we plug in 34 to the cost, we get 11,744. Okay, for number 3, I'm going to do that down here. I need a secondary equation, a primary equation, and then eventually the first derivative. Whatever it says to maximize or minimize is the primary equation. So if I have two numbers and it's the sum of their squares, so that's x squared plus y squared equals the sum. And the sum of them is our secondary equation, x plus y is 16. So now what we have to do is isolate a variable in our secondary equation. So y is 16 minus x. We're going to substitute that in here. But when you have 16 minus x squared, that is 16 minus x times itself. FOIL or box method. So we have 256 minus 32x plus x squared. And then when we combine our like terms, that's 2x squared minus 32x plus 256. So now we have to take the first derivative. Set it equal to 0. Solve it. So 8 is x. I'm going to take that back up here. So y is also 8. Okay, so for number 4, the perimeter and area, but we want the smallest perimeter. So that is what we're going to eventually find the derivative of, and the area is 16. So I'm going to isolate y again, substitute it in to the perimeter equation. Now we need the derivative, but to find the derivative, I'm going to make my perimeter equation 32x to the negative 1. So now the derivative is 2 minus 32x to the negative 2. I'm going to set it equal to 0. Move the negative exponent to the denominator, and now I don't like an exponent in the denominator, so I'm going to multiply the entire equation, every term, by x squared. Now solving it, we're going to move the 32 over, divide by 2, square root both sides. So we get plus or minus 4 is x. But because it's a physical situation of a rectangle, it's just positive 4 is our answer. And then finding the other dimension, I'm going to plug in 4 for x. We also get 4 for y. Okay, so 5 is very similar. So I'm going to jump to 6. Maximum volume, so that's what we will eventually take the derivative of. And that's length times width times height. So then surface area, it's open on the top. So the surface area is 108. I'm going to have one base of x squared in the bottom. And then this front side is x by h, and there's 4 of them. So the easiest variable to isolate is h. And divide by 4x. We can simplify 108 divided by 4. So we get 27 divided by x minus, these x's can reduce, x over 4 equals h. We're going to substitute that into the volume equation. Distribute the x squared. Oops. Sorry, instead of that h, this is supposed to be a 4. We can reduce here, so we get 27x minus, and I'm going to make that 1/4 x cubed is our volume. So now that we have the volume equation, we need the derivative. I'm going to set it equal to 0. I'm going to move the fraction to the left so it's positive. So now to move the coefficient, we'll multiply by 4/3. You can multiply this right-hand side in your calculator. I'm going to reduce this, so we get 36. Square root both sides, and x is 6. I'm going to leave out the -6 because it's a physical box, so it can only be positive. So if x is 6, we need to find h, because it says what are the dimensions. So 27 divided by 6 minus 6 over 4, and we get 3. So x is 6 and h is 3. Okay, so now for 7, if the pages contain 24 square inches of print, that's this area here. So x times y is 24. The margins at the top and bottom are 1.5. So what that means is this length is 1.5, and this length is 1.5. So this total y length is y plus 1.5 plus 1.5, which is 3. Then it says the margins on the left and right are 1 each. So that means this total length here is x plus 2. And we want to know least amount of paper used. So that's also an area, but that's going to be the outside dimensions of x plus 2 times y plus 3. So now we have to isolate a variable from this first equation, and I'm going to isolate the y. So y equals 24 divided by x. And then we're going to substitute that into the equation on the right. Now box method or FOIL. So when we do x times 24 over x, we get just 24. And plus 3x from here. The inside is plus 48 divided by x, and lastly, plus 6. So the area simplified is 30 plus 3x plus, and I'm going to write this as 48x to the -1 so that I can easily take the derivative. So that's 3 minus 48x to the -2. We're going to set it equal to 0. I'm going to put the x to the negative 2 back in the denominator. I'm going to multiply every single term by x squared so that we don't have a fraction anymore. I'm going to move the 48 to the left. Divide by 3. Uh-oh. So we get 16 is x squared. So 4 is x. But what does this problem ask for? Sorry, this writing is in the way of my problem. What should the dimensions of the page be? So that means I need the outside dimension here. So that's going to be 6 inches. But now I need y to be able to find the vertical length. So y is 24 divided by 4, which is 6. So this side is 6 plus 3, which is 9. So it's 6 inches by 9 inches. Okay, so on review number 2, there is nothing different, but I'm going to do number 5 since that's the hardest one on the page. So if it's going to contain 50 square inches of print, that's the inside area. So x times y is 50. The margins on the top and bottom are 2, so that's here. So this side is y plus 4, because there's 2 2's. And the left and right are 1, so this side is x plus 2. So the area of the whole paper is x plus 2 times y plus 4. We're going to isolate one of the variables, substitute into the right equation. FOIL box method, distribute. And then the only like terms I have are the 50 and the 8. And I'm going to write that as 100, x to the negative 1, so I can take the derivative. So a prime is 4 minus 100, x to the negative 2. Set it equal to 0. I'm going to multiply everything by x squared to eliminate the fraction. Move the 100 over, divide by 4, and we get x is 5. Which means y is 50 divided by 5, which is 10. And the problem specifically asks for the dimensions of the page. So x plus 2 is 7 inches, and 10 plus 4 is 14 inches. Okay, so number 2 on this last review, we haven't done one like this yet in the video. I'm going to draw the picture. We're going to cut out the corners, and they're square corners, so each corner is x. We've got 16 by 21, so that means this top dimension is 21 minus 2x once we cut out the corners, and the vertical one is going to be 16 minus 2x. We want the largest volume, so volume is length times width, and then the height of the box is going to be the x that we cut out from this corner. Multiply those together, take the first derivative, set it equal to 0, and solve. Okay, for number 4, for the fence that we need, that's 1, 2, 3 x's plus 1, 2, 3, 4 y's equals 1,000. And we want to maximize area, so area is x times y. I'm going to purposely isolate the y since 1,000 divides by 4. Divide everything by 4. We get y is 1,000 divided by 4, 250 minus 3/4 x. We're going to substitute that in here at the area. Distribute the x. Take the derivative. Set it equal to 0 and solve. So for 6, we're going to mail a rectangular package with a square base. So this is x by y. And girth is the perimeter of the base, which is here. So that's 4x plus y equals 108. We want to maximize the volume, which is length times width times height. So that's x squared y. It's easiest to isolate the y. We're going to substitute that into the volume equation. Distribute the x squared. Now you need to take the first derivative, set it equal to 0, and solve.